Good day, viewers. My name is Dr. Chris Esekaibe. I'll be taking you another topic in statistics today, which is how to calculate quartiles, deciles, and percentiles from grouped data. How to calculate quartiles, deciles, and percentiles from group data. These three, quartiles, deciles, and percentiles, are under the topic treated in statistics, and this topic is known as measures of position or measures of location. This is what we shall be looking at today for ungrouped data. A lot of authors have not really spoken much about this particular topic, especially for ungrouped data. Please be patient with me as I run through this topic from the beginning to the end. Be patient to watch it from the beginning to the end. I will be taking them one after the other: quartiles, deciles, and percentiles. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. It's a channel that has a lot of classes for mathematics and statistics topics. And if you want me to teach on any topic that is challenging, you can send me a message and let me know, and I will do the teaching and upload the video. Please again subscribe to my channel, Dr. Chris Esekaibe, and click on the bell button by the side of the subscription, so that anytime I post a video, you will have a notification whenever a video is posted in that particular channel. So when we talk about measures of position, we want to see the position of each data point in this data set. We want to know the location of each data point in this data set. A lot has been said about grouped data, but not really much has been said about ungrouped data. As you follow this video from the beginning to the end, you will see that calculating quartiles, deciles, and percentiles for ungrouped data is pretty cheap and it's very easy. The first thing you need to do is to array the data. You have to array the data from smallest to the highest, or from the highest to the smallest. That is the first thing you need to do. You have to array the data. So the smallest here is 2, followed by 4, followed by 4, followed by 6, followed by 9, followed by 10, and 11. The observations is 7 in number. You can count 1, 2, 3, 4, 5, 6, 7, and from the raw data, that is the original data, you also count 1, 2, 3, 4, 5, 6, 7. The essence of counting is to ensure that no data point is left out. You ensure that no data point is left out. Then the next thing you need to do is to position the data point. You can position them. So let me position them. So I'll create a way to position them here. This first one will be in the first position. This is the second position, third position, fourth position, fifth position, sixth position, and the seventh position. You will position them or rank them in the order that you have arranged them. So now, having done this, you will also agree with me that the median is, I want to start with the median. Most people don't know that the median is also a measure of position. It's also a measure of location. The median shares the data values into 2 equal parts. And whenever the median is to be calculated for ungrouped data, remember we are looking at ungrouped data today, then our next video will be on grouped data. For the median for the ungrouped data is very simple. The n plus 1 1/10 item divided by 2. So you have the n plus 1. N is the number of observation. The n plus 1 item, the way it has been arranged, that is the median. Why are you dividing by 2? Because the median shares the data point and the data values into 2 equal parts. So if you want to get that here now, our n here is 7. We're going to have 7 plus 1 all over 2, and that will be 8 all over 2, that is 4. So the item in the fourth position will now be the median. The fourth item will now become the median. So let's count. This is the first item by position, this is the second item, this is the third item, this is the fourth item. So by implication, it means that the median is equal to 6. That is what it means. So the median, though a measure of central tendency, is also a measure of location or position. It has divided the data set into 2 equal parts. Now I want to go into quartiles. I started with the median so that you can get it clearly. I want to go into quartiles. There are 3 of them, 3 measures of position, or you can call them measures of location. Now the quartiles. The quartiles is gotten from the word quartile. It means you are sharing the data values into quarters or into 4 equal parts. Sharing the data set into 4 equal parts. That is what quartiles are. You are sharing it means quarter, you are sharing it. When you say 1/4 of a particular group, it means you are sharing that group into 4 equal parts. It means you are sharing it into 4 equal parts. That is what it means. So now, what it simply means again, if I want to get the first quartile is Q1. And Q1 is calculated this way. The n plus 1 item all over 4. You are sharing the data set into 4 equal parts. The n plus 1 over 4 item, that is what it means. Now if I want to get my Q1 from here, my n is 7, so it will be 7 plus 1 all over 4 is equal to 8 all over 4, and that is equal to 2. That is equal to 2. So that means the Q1, which is the first quartile, will be the second item as arranged in the data set. What is the first item here? The first item is 2, then the second item is 4. So by implication, it means that our Q1 is equal to 4. So the first quartile is equal to 4. So quartile simply means sharing the data set into 4 equal parts, and the n plus 1 item divided by 4, then the position, the item, or the data point in that particular position will eventually become the first quartile. Now the second quartile, which is denoted as Q2, is given as this n plus 1. Because it's the second quartile, you put your 2 outside. 2 into n plus 1 all over 4. The item in that particular position will now form the second quartile, and that is equal to 2 into 7 plus 1 all over 4. So this will be 2 into 8 all over 4. That is equal to 16 over 4, and that is equal to 4. So our Q2 will be equal to the item in the fourth position. So Q2 will now be equal to, this is the first position, the second position, the third position, the fourth position. The item here is 6. That is the data point that is in the fourth position. So our Q2 will now be equal to 6. Our Q2, which is the second quartile, is now equal to 6. Now, it is also good we calculate the third quartile. Now, calculating the third quartile is as easy as calculating the first and second quartiles. Now, let's go ahead and do that. If you come here, you will see that your Q3 is gotten, because it's the third quartile, you must the 3 into n plus 1 item divided by 4. You must divide by 4 because you are looking for the quartile. Quartile means sharing the data set into 4 equal parts. The item in that position will now be the third quartile. This will be 3 into 7 plus 1 all over 4. It will be 3 times 8 all over 4 is equals to 24 over 4. That will be that is 6. So the item in the sixth position will now form the third quartile. So item in the sixth position. Now you count. Therefore, our Q3 will now be equal to, look at the first quartile, at the first position, second position, third position, fourth position, fifth position, sixth position. The item there is 10. So our Q3 is 10. The third quartile is 10. So this is how you calculate them by position. You have to rank the data set, you position them, then you look for the one in that particular position you have calculated. So our Q1 is 4. That is the second item by ranking, which is 4. Then our Q2, which is also equal to the median, is the item in the fourth position, which is 6. Then our Q3, which is the item in the sixth position, and that is 10. So this is how we calculate them. Now there is what we call the interquartile range and semi-interquartile range. So the interquartile range is denoted as IQR is equal to Q3 minus Q1. That is what the interquartile range is. So from here, our IQR, which is our interquartile range, is equal to our Q3 by calculation is 10 minus our Q1, which is 4. The first quartile is 4. So our interquartile range is 6. 10 minus 4 equals 6. And there is what we call the semi-interquartile range. And it's written this way: XIQR, and that is given as Q3 minus Q1. That is the third quartile minus the first quartile all over 2. And that will now be equal to 10 minus 4 all over 2 is equal to 6 all over 2 and is equal to 3. So our semi-interquartile range is 3 for this data set. So it is as important as this. You know one very use of the interquartile range? The interquartile range helps us to detect outliers. An outlier is an extreme value. It's a value that is significantly different from other values in the data set. That is what an outlier is. It can come as a result of error, or it can come as a result of other problems. So there are further investigation that can be done to do extensive study on outliers. So it is an extreme value. It's a value that is different from the values in the data set, and it may be as a result of error or some kind of abnormalities or abnormalities in the data set. Now this is how you detect outliers using the interquartile range. Note our interquartile range is 6. There is from this data set we can check if there is any suspected outlier in the data set. We can check. So our interquartile range IQR is equal to 6. Now this is what we use with 1.5 multiplying the interquartile range. This is what we use to check for suspected outliers in the data set. This will be 1.5 times 6, and this is equal to 9. When you get this value, the first thing you get the Q3, which is the third quartile, you get the Q1, which is the first quartile. You subtract the first quartile from the third quartile and get the interquartile range. Then you multiply the interquartile range by, this is a form of checking for suspected outliers in a data set. You multiply by 1.5. Now this value that you have gotten, now by implication, this is our Q1 in the second position. This is our Q2 in the fourth position, and this is our Q3 in the third position. Now the first thing you need to check, any value that is below the first quartile, any value that is below the first quartile from the data set, not from the position, any value that is below the first quartile Q1 that is lesser than this 1.5 multiplied by the interquartile range, if that value is lesser than this value, then it is a suspected outlier. And look at the only value that is below the first quartile, that value is 2, and 2 is less than 9. So suspected outliers are from this data set are, the first one is 2. You check below the first quartile, the only value there is 2 and it's lesser than this value of 9. Then again you go to the third quartile, the values above the third quartile. Again we have only one value, that is 11. If that value is above this 1.5 multiplied by the interquartile range, then that value is also a suspected outlier. And now this 11, this is our Q3. Our Q3 is here. Our Q2 is 6, and our Q1 is 4. So our IQR, which is the interquartile range, is 6. Then multiply by 1.5, you have 9. So now below this Q1 is 2, and it's lesser than this, so it's a suspected outlier. Then above this Q3 is 11. This 11 here is higher than this value. If it's more than the value, then it is also a suspected outlier. So we have 2 suspected outliers in this data set. They are 2 and 11. They are extreme values. So they are suspected outliers. Don't be surprised that when you calculate the mean, the mode, and the median for this data set, the mean will be a bit different from the mode and the median because of the outlier. You can do that check on your own. So by this calculation, this is one way of investigating outliers. Though further studies, further investigations can still be done, but this is the primary investigation, the primary formula used for determining or to determine suspected outliers. So 1.5 multiplied by the interquartile range, you get that value. If any value below the Q1 is lesser than it, it's a suspected outlier. We have only one value below the Q1, which is the first quartile, and that value is 2. 2 is less than 9, so 2 is a suspected outlier. Then we have the third quartile, which is 10. We have only one value above it, that is 11, and 11 is now more than 9, so it is also a suspected outlier. So the suspected outliers for this data set are 2 and 11. So this is how we calculate the quartiles for ungrouped data. Now this takes us to deciles. Let us see how deciles can be calculated from ungrouped data. Deciles simply is a measure of position or measure of location. It simply means sharing the data set into 10 equal parts. This is what deciles are. You are sharing the data set into 10 equal parts. And when this is done, you will be able to determine the position. Now, for instance, if I want to get D1 here represents the first decile. Decile is from the word decimal, is from the word decade, just sharing into 10 equal parts. You are sharing these data sets. Before you start sharing, you must array or arrange the numbers in ascending or descending order, and you give them their various ranks or position. Now this D1 is simply n plus 1, the item element plus 1, then all over 10, because you are sharing to 10 equal parts. For instance, the item there in that position will now be the first decile. If I want to get, for instance, my D3, it will be 3 into n plus 1 all over 10. So we are sharing into 10 equal parts. If I want to get my D5, which is the fifth decile, it will be equal to 5 into n plus 1 all over 10. If I want to get, for instance, my D8, this will be equal to 8 into n plus 1 10 all over 10. So you are sharing the data set into 10 equal parts. That is what it means. Now, the first thing I need to do, let me calculate the third decile, the fifth decile also. You know, the 5 is the middle of 10. So the fifth decile is also equal to the median. The same way the 2 is the middle of 4. That's why the second quartile is also equal to the median. So we'll look at that. So now let us solve 1 or 2. Let us calculate 1 or 2 deciles. Maybe the third decile, the fourth decile, or maybe the sixth or seventh decile. By the time we take 1 or 2 examples, it will be easier to understand. Now the third decile D3, this will be 3 into n plus 1 position all over 10. So this will be 3 into, again, n is 7. The number of observations is 7. It will be 7 plus 1, n is 7, all over 10. The item in that position, that will be 3 times 8 all over 10. That is equal to 24 over 10 is equal to 2.4. This one is becoming very interesting now. Now, how do you get the exact value for this D3? You can see now by position is 2.4. What is the data point in the second position? So that means this D3 is between the second and third position, 2.4. So the first thing we do to calculate the actual value of this third decile is to pick the element in the second position. That is, you pick the second item plus 0.4, which is the difference between the second, you know, is 2.4. So the second item is this 2 here, then 0.4 is this one, multiplying the difference between the second and third items. Now I will explain. Now our D3 is equal to the second item here is 4. That is what we have gotten because it's 2.4. So you write it down 4. Then plus this 0.4 that is left, which is 0.4, we are not going to throw that away. So you are going to multiply it by the difference between the second and the third, the items in the second and third positions. The one in the third position is 4, minus the one in the second position is 4. So this will be equal to 4 plus 0.4 into 0. 4 minus 4 is 0. So it will be 4 plus 0 and is equal to 4. So our third decile is 4. Now we take another example again and see how this is calculated. Just take note of this procedure. We are now going to calculate D4, which is the fourth decile. You come here now, we want to calculate the D4. Ensure you are taking note of all this. Take note of it. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the share button. Share my videos on your social media platform, your WhatsApp status, your Facebook, and the rest of them. Now the D4 is equal to 4 into n plus 1 item all over 10. Because you are shedding to 10 equal parts. This will now be 4 into 7 plus 1 all over 10. This is now 4 times 8 all over 10 is equal to 32 over 10 is equal to 3.2. You see that? So that means the item in the third 3.2 position. Now we have to calculate the exact value of that D4. So our D4 will be equal to item in the third position, item in the third position plus 0.2 left into the difference between the third and fourth items. So this is how you calculate it. D4 is equal to the item in the third position is 4. So plus 0.2 into, now the item, the D4 is the one in the 3.2 second position, 3.2nd position. Now we have taken the one for the third position, which is 4. Now between these 3 and 4, we are going to calculate this 0.2. So the fourth item here is 6, the third item is 4. So you now have 6 minus 4. So this will now be equal to 4 plus 0.2 into 6 minus 4 is 2. So that will now give you 4 plus 0.4. So the actual value of our fourth decile is D4 is equal to 4 plus 0.4 is 4.4. That is the exact value of our fourth decile. I will take 2 more examples on decile before we move to percentiles. Please be patient as you watch this video to the end. This topic is very critical. If you understand how to calculate quartiles, deciles, and percentiles for grouped data, for ungrouped data, that for group data is easy. Most authors have not dealt on this very, very well. That is why I'm taking my time to explain it. Now, if we want to calculate our D5, we'll calculate D5 and later D7 or D6 before we move to line. Let's calculate our D5. Our D5 is the fifth. 5 into n plus 1 item all over 10. So this will be 5 into 7 plus 1 all over 10 is equal to 5 times 8 over 10 is equal to 40 over 10, and that is equal to 4. So our D5 is equal to item on the fourth position. So our D5 will now be equal to the one on the fourth position, first position, second position, third position, fourth position, and that value is 6. So our D5 is 6. And you can see this is the same thing as the median. The median is 6. The middle of 10. Deciles means dividing or sharing the data set into 10 equal parts. And 5 is the middle of 10. So that is the median. So the D5 is equal to the median. The Q2 is equal to the median. So I will calculate D6 before I now move to the interdecile range. We can also calculate interdecile range. So my D6 will be equal to 6 into n plus 1 item all over 10. That is 6 into 7 plus 1 all over 10 is equal to 6 times 8 over 10 is equal to 48 over 10 is equal to 4.8. So the item in the 4.8 position, is our 6th decile. So it means by implication that our D6 is equal to item in 6th position, no, item in 4th position rather, because it's 4.8 plus 0.8, you can see 0.8 there, into the difference between the fourth and 5th items, because 4.8 is between 4 and 5. So my D6 will be equal to the item in the 4th position. The item in the 4th position is 6. So it will be 6 plus 0.8 into, now the item in the 5th position is 9. The 5th position is 9. The one in the 4th position is 6. It will now be 9 minus 6. So it will now be equal to 6 plus 0.8 into 9 minus 6 is 3 is equal to 6 plus 0.8 times 3. Do we have 2.4 plus 2.4. Now my D6 will be equal to this of 6 is equal to 8.4. That is my 6th decile. You can go on and on and on and on to calculate whichever one you want to calculate. Now I want to also tell us that apart from having the interquartile range and the semi-interquartile range, we can also have the interdecile range. Interdecile range between two deciles. For instance, I can say I want to calculate the interdecile range between the 6th decile and the 3rd decile. Let me say interdecile range between D6 and D3 is simply, so interdecile range is how it is written. Interdecile range between the 6th and the 3rd decile will be given 2 deciles. Will now be equal to our D6 that we just calculated is 8.4. So 8.4 minus, then our D3 that we calculated from the beginning is 4. 8.4 minus 4. So our interdecile range between D6 and D3 is 8.4 minus 4, which is equal to 4.4. Then we can also have our semi-interdecile range. Semi-interdecile range between the 2 deciles is simply, you can call it X. Semi-interdecile range is equal to, between D6 and D3 will be D6 minus D3 all over 2. For semi, anything semi you are dividing by 2, and this will be equal to, because it's between 2 deciles. D3, you can find interdecile range between D7 and D2, between any two deciles. One is higher than the other. So this will now be the value I've already calculated, which is 4.4 all over 2. This will be equal to 2.2. So we can calculate the deciles, the interdecile range, and the semi-interdecile range. Now this takes me to the third measure of position, which is the percentiles. Third measures of position or location, the percentiles. You will agree with me that percentiles are gotten from the word percentage, and percentage is 100. So it means percentiles means sharing the entire data set into 100 equal parts. Sharing the entire data set into 100 equal parts. Now, for instance, if I want to get my P1, that's the first percentile, this is simply n plus 1 item all over 100. If I want to get P25, it will be equal to 25 into n plus 1. It will be 25 into n plus 1 all over 100. That is the 25th percentile. If I want to get, for instance, the 50th percentile, which is P subscript 50, it will be equal to 50 into n plus 1 all over 100 percentile. Of course, if I want to get the 68th percentile, P68, it will be equal to 68 into n plus 1 position all over 100. So you are sharing the data set into 100 equal parts. That is what we mean by percentiles. So I want to start now by calculating some percentiles. Then we look at inter-percentile range and semi-inter-percentile range. We calculate 1 or 2 or 3 percentiles. Then we'll look at how to calculate the inter-percentile range and the semi-inter-percentile range. Now let us start by calculating the 25th percentile, P25. This is simply 25 into n plus 1 position all over 100. And that is simply 25 into 7 plus 1 all over 100 is equal to 25 times 8 all over 100, and that is equal to 25 by 8 is equal to 200 over 100. 200 over 100, and is equal to 2. So our P25 is equal to item in the second position. And what is that item? Our P25 is equal to 4. You understand that you can see that the P25 is also the same thing as the first quartile, because if you take a quarter of 100, it's 25%. A quarter of 100, 1 over 4 times 100 is 25%. And from our Q1 is 4. And our P25, which is the fourth percentile, is also 4. So it's as simple as that. We can also go ahead and calculate the 45th percentile. 45th percentile, for instance. We can calculate and so on and so on. Whichever one you wish to calculate. Our P45 is equal to 45 into n plus 1 all over 100 position, and that is equal to 45 into 7 plus 1 over 100 is equal to 45 times 8 all over 100, and when you multiply 45 by 8, you will get 360. 360 all over 100 is equal to 3.6. So the item is between the third and the fourth position. So our P45 will be equal to item in the third position plus 0.6. The difference here is 0.6 into difference between third and fourth items. And this simply P45 is equal to the item in the third position is 4. So it's 4 plus 0.6 into, now items in the third and fourth position, of course that in the fourth position will be higher. It will be 6 minus 4, that in the third position is 4. That you will now have 4 plus 0.6 into 2. It will be 4 plus 0.6 into 2 is 1.2 plus 1.2, so it's equal to 5.2. Now that means we have the item between the 5th and the 6th position. We have the item between the 5th and the 6th position. So now it simply means that we are going to calculate the item P45 is now equal to the item on the 5th position, the item on the 5th position. So we plus that particular one we have there. Now the item on the 4th position, the one on the 4th position plus that particular item that you have there. So that is what we have for our P45. The item on the 3rd position is 4, then the one in between, the 0.6, is there. Now let us see how we can calculate the P70, or let's say P50 for instance. Let's get the P50, that is the 50th percentile. Let's see how we can calculate the 50th percentile. So our P50 is equal to 50 into n plus 1 all over 100, and that is equal to 50 into 7 plus 1 all over 100 is equal to 50 times 8 all over 100, and that is equal to 4,400 all over 100, and that is equal to 4. So the item in the 4th position, that P50, is equal to the item on the 4th position, and that means our P50 is equal to the item on the 4th position. You can see is 6, and that is the median. 50 is the middle of 100, so you can see that our median is 6, our P50 is 6, our D5 is 6, and our Q2 is 6. These are all middle values. These are all middle values. These are all middle values. Then lastly, let's calculate the 75th percentile. The 75th percentile, P75, will be calculated towards 75 into n plus 1 all over 100, and that is equal to 75 into 7 plus 1 all over 100 is equal to 75 times 8 all over 100. 75 times 8 will now be equal to 600 over 100. That is 600 over 100. That is 6. So the item in the 6th position. So our P75 is equal to the item in the 6th position. So that's why we call it measures of position. So our P75 will be equal to the item in the 6th position is 10, and this is equal to the 3rd quartile, and it's also equal to D7.5, that is 7.5 decile. So this is the 3rd quartile, 3/4 over 100, and that is what we got is 10. So this is how you calculate your percentiles. Before I go further, please subscribe to my YouTube channel, Dr. Chris Isekagbe. The channel has a lot to do with the teaching of various topics in mathematics and statistics. Today, we are looking at how to calculate quartiles, deciles, and percentiles for grouped data. So it is important you know this. Now we want to look at interpercentile range. Interpercentile range. Our interpercentile range, Our interpercentile range is given as, for instance, if I want to calculate the interpercentile range for 2 percentiles, maybe between P75 and P45, maybe between P75 and P45. For instance, you will first of all calculate the P75, which is the 75th percentile. You also calculate the 45th percentile. So this will simply be P75, the higher one, minus P45. And the P75 that we calculated is 10 minus our P45 that we calculated earlier is 5.2. And this will be equal to 4.8. So the interpercentile range between the 75th and the 45th percentile is 4.8. Now there's what we call the interpercentile range. Now we want to also calculate between the P75, the 75th percentile, and P45, the 45th percentile. So the semi-interquartile is S, interpercentile range is now equal to P75 minus P45 all over 2 is equal to 4.8 all over 2, and that is 2.4. So the semi-interpercentile range between the 75th percentile and the 45th percentile is 2.4. So it will interest you to know that the following condition holds. Or the following facts hold. You can check on your own. Our Q1 is equal to D 2.5 is equal to P25. Our Q2 is equal to D 5 and is equal to P50. While our Q3 is equal to D 7.5 and is also equal to P75. Of course, this one is also equal to the median. So these facts have been established on this particular topic: measures of position or measures of location. Now, I want to drop you with a set of data that you are going to play with. You will check, you will prove all these things for this particular set of data, though we have calculated some of them, but I want to give you a new set of data that you will use to practice this. The first set of data that we just finished with has 7 observations, but this one I'm giving has 8. We have used it before. 4, 5, 3, 3, 4, 4, 6, 5. So this one here, your n is equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. So use this to show that from here Q1 is equal to this, Q2 is equal to this, Q3 is equal to this, using this data set. I will be bringing the solution of this particular problem in my next video. Please watch out for my next video. I will be using this problem to prove this fact. Then also, please subscribe to my YouTube channel, Dr. Chris Esekaibe. Click on the bell button by the side so that you will be able to get a notification anytime I upload a new video. Once again, I want to appreciate you for watching. I believe if you play this video to the end, you will understand extensively how to calculate deciles, how to calculate quartiles, and how to calculate percentiles for ungrouped data. The one for group data will be coming up later. So please take this problem, practice it. I will come up with the video in a few periods or a few moments. You will get the answers and you will see if you have really understood it. You can play the video again and again for better understanding. Thank you for watching today's video. Subscribe to my YouTube channel, Dr. Chris Esekaibe, and click on the bell button. Share my videos on your social media platform, your WhatsApp status, your Facebook, and the rest of them. Thank you very much for listening. God bless you. Enjoy the rest of the day. Thank you.